Hello, welcome everybody to a new session where we are continue working with the animations. So let me, okay, let me check that all is working fine. Okay, the chat. Mhm. Okay, okay, okay. So what we are going to do today, we are going to continue with uh, the new animation and animator classes components. So in last session we created in the engine a new package called animation. In the animation, so let me close all of this. In the animation, this is not used. Okay. We have an animator. The animator is more or less just a list of animations with some actions. The actions are mainly to select first animation, next animation, or any animation if we know the name. We can we can get information about the time, and we can get the output value. So this is more or less in the first example. This animator works with a list of an interface animation, and we implemented only one of them that it's called linear float. So it provides float values. So this is what it provides. So just provide the value of a linear function between here the value free between the minimum value and maximum value in the time frame between min time and max time. I think it's not used this one, so we forget to remove that. Okay, that was not. And you can play the animation once or multiple times. So this is the loop times. And we face some issues with the end of the animation. So let's check how it works. So here, this is the only window, and the debugger window is the only one that has the animation. And when we click this button, the animation starts, animation ends. So just clicking and clicking, you start and end the animation. And the animation, we have two. We are changing two values right now. We are changing the width and height, and also we are changing the rotation. So all these three actions together at the same time are producing this effect. So let me share where is defined. Here in scene number 2, we have a window effect. The window effect is just it has an animator. Animator is just a list of animations. So we have a maximize animation and minimize animation. So these are the both animations. And how it is implemented in the rules in the event list here at the end. Mm, we have whenever there is a draw update, so when it's time to update the drawing, we get this event. Um, we get the value. So mhm, mhm, we get the value from the animator. So the animator calls the current animation and gets the y value. For the x-axis is the time. So for the current time, it gets the animation. and the animation value, and it provides the that animation value, this y output, this is a float, in this event, output event, this window effect animation value got, and it's provided to three different uh, events or rules. They are the transformation width, the transformation height, and the transformation rotation. So I'm doing using the same value for all of all of three aspects. So what we want to do today is just to create a different animation that instead of doing a linear, so let me move here. Mhm. Yes, you can see it now. Let's zoom it. Mm, okay, this is what we get from last day. So it's just a linear from the minimum value to the maximum value. And what we want today is just instead of these standard animations, what we want, no, not this. Mm, Okay, what we want is, let me change the color, is to have a different um, function, but it will have some keyframes. So the keyframes in the animation, so we will have a minimum time. This is not good for drawing. Mhm. This is the, hmm, it's not the mean time, and we have the maximum time, max time, max, and this is the time. So between the minimum, let me remove this one. Oh, not that. Hmm, it's difficult. Okay, we cannot move it here. No, this program is difficult to manage. Okay, I know. We cannot move it. Not easy. Okay, let's remove, remove. So let's draw it. This is the minimum. For example, this is the maximum. So if we have some output values, and the output values right now it was a minimum and a maximum value, and it was a linear interpolation. So it goes from the minimum to the maximum or whatever, or it could be a function like a sinus or cosine or whatever. What we want now is to have some keyframes. So what is a keyframe? A keyframe is just in the middle for some time after the minimum time. So we define the value. For example, here we want this value, here we want this one, and this one. And the output, it could be the last one, and the minimum, let's say that it's the minimum. So between the keyframes, so we have the values, the different values that we want to output in different keyframes. So we have at this time, for example, time 0, we want to output 0. At 1, we want to output 3. At 3, we want to output 2 or whatever. And what we need is just to provide a function between them. So usually we can have a linear interpolation. So this will be the output. So what can we, why can we use that? And this is very, very important when you do some animation with body or bones. So it's very important. But for example, in the case of the window, we will be able to do things like imagine, no, not there. Imagine that we have the window. This is the screen, mm, and you have the window here. So this is our window, and what we want to do. Okay, no. Can I select? No. Okay, it's very difficult. Okay, imagine that what we want to do is just to draw that window, uh, to move, to do some movement, just to say, okay, go to here, later go down, just move here. So do this, follow this path. So this path and then minimize or do whatever. So in this case, for example, uh, what we want is it's not the same as it will minimize. Minimizing the window, we have followed a linear path. So it's just to go there all the dimensions, just minimize and go all the aspects, the width and the height, moving in the same way, in a linear way, just to the end. But here, for example, we want to change the x here, and it's not linear, so this is incrementing the x. Here we are want to keep the x-axis, the x component, and it's the y what is increasing, and later the x will be decreasing. So that in a graph it could be something like, for example, let's put two of them. So imagine that we have here, um, let's choose this one for the x. So imagine that the output here is the x, the output value. So we start with, for example, at 10% or 20%. So we start here and we go increasing this time. So we go to the maximum. So we go here. This is a linear interpolation from here. Next, we keep the position of the window at the most left position. So this is just linear, so there is no change. So the next keyframe has the same value. And later, we move it back. So we reduce the x value to the beginning. So the x here is the same. Here it's the same. So this is the movement of the x coordinate. For the y coordinate here, it's the same. So it's at the minimum. So here it's the same. Later we increase the y position. So here this is the y position. The y is increased, and this is with we keep. So it's more or less this way. So we have two outputs. We have two different um, graphs with some keyframes. So keyframe is just to take a screenshot of what you want in some time. So say it here at t sub 2. So t2, t1, t3, and t4. So when time is the first time is here, this is time 2, time 3, and time 4. So, and we with this keyframe, so we need to keep, because we don't want to get a linear interpolation, for example, for the x component from here to here, because it will be no movement. It will keep at the same point without moving. So we can do that with 1, 2, 3 animations. So it could be 1 plus 2 and 3 different animations. So you can have multiple animations. different animations. This is a composition, or you can have some keyframes just to keep the intermediate state of the window or of the object. It could be an arm or legs or whatever. So it's important. Or just imagine that, for example, you are doing another game and you have here some enemy, and the enemy needs to do this path to go here, and then go back. So if you want that they repeat it's in the patrol, this is the patrol path. So you can add this as an output just to say, okay, at time 1 is this position, time 2, time 3, and time 4 you repeat the loop. So do this. So what you want to keep is these uh, key positions and just interpolate between them. So this is nice because you can add very complex situations, very complex paths easily, and you can have very complex animations with very details. Mm, with it's very easy. So right now what we are going to keep is linear interpolation between of them. For more advanced animations, for example, bones or whatever that is when you need to interpolate angles or rotations, it's better to have a spherical interpolation, spherical linear interpolation. But right now we will keep the linear interpolation between the keyframes. So let's move back to the programming screen. So we need to provide that. So right now we have this animation. This animation only have minimum maximum value, minimum time, maximum time. So this is the standard one. So we want to create a new one that provides the same output. So to implement this interface, but has many different options here. So let's start with that. So let's start adding a new animation. Let's start with another float, but instead of linear, we can call it keyframes. So new class. It could be animation keyframe float. Yes, it could be that one. We want to implements the e-animation. So we need to add the basic functionality. What happens? Why it's not providing me? Okay, I know. I don't know why. Okay. And this is the e-animation interface. Okay, so later we will need to add the logic here just to provide all of this one. So the first one, get name, is very easy. So we are going to reuse from the other animation. So here, animation, get name, get animation name. Okay. Let me add here the getters and the setters. Source, generate getters and setters. Okay, not there. Here. and these are the headers and setters. Okay. Okay, that's correct. So we have the first one. Okay. So next, what we need to think is some. We need to provide some a way to store the different keyframes. So right now, the keyframes are more or less just a value and some time. So we can keep, maybe we can force to have a minimum value, maximum value. So it could be the same time as we have for, um, yes, what we have for. Okay, so let me try to define here a new one. So let's do here, this could be the new one. Instead of animation linear, it could be animation keyframe float. So the animation name, it could be random movement. Oh, yes, loop times. Okay, I can keep it or just okay, just keep it. So instead of minimum and maximum value, what we need is a combination of values and times. So we need value and time. In this case, values are floats uh, and time is long. White is float here. Strange because it's not minimum time. Okay, maybe I use this in a different for some reason, but it's not what is expected. So let me check. What happens? Okay, only here. No big changes. Long and long. I don't know. I need to change this one. Long. Any other issue? No. Later we will check this. Okay, so instead of float and okay, we will need to change this to long. And the same here. It's the same values. Yes, the same values. So just copy and paste. Okay, let me check before creating the new one. So let's check that those changes to long are not impacting the game. Okay, minimize, maximize, minimize, maximize, move, drag, minimize, maximize. Okay, it works. So works as expected. So this will be the next one. So instead of float and long here, we need some way both together. So it will be nice to say, okay, it's in this value at 0. So yes, give me 0.001 at time 0 and give me 1.0 when it is 7 seconds, no, 700 milliseconds. So maybe it could be this way, but and this is not this is not a float. So I think that we have This one created, I have used that in the past in the animation class. So the animation, the previous one, it has an animation values and log for the seconds. Mhm. So in the past, in the keyframes, it was already created using instead of mhm, this is a float array with the values. Let me use the same name. It was animation nanoseconds. Okay, let me use new name. So it could be the keyframes. This is the values because in the future, so the we have two values from 0.001 to 1.0, and we have a long array, and that's are the key in the keys. Okay, it could be the keys, and the keys are so we get at 0 at this minimum time 0, we will get this value. Okay, let's add something strange here. So let's add some in order to see this one. It's difficult. I think that we can increase the value, but not to, for example, only to half the size of the window, and then keep it some time there. And so, for example, this is okay. So, okay. So right now it will take. Okay, let give 1 second for each step. So the total animation is 1, 2, and 3 seconds. Okay, so I can use for the keys the total time from the beginning or just the duration of that step from the previous one. So it could be from this value to this value. So let's move back here. So when we provide this, imagine that this is the value M, capital M, and this is the lower M. So we can provide a list of, for example, for the white it will be M, M, capital M, capital M. And we can provide this time from the 0, so it could be T1, T2, T3, and T4. Or it could be just be the delta times. So it could be T minus 0, T2 minus T1, or T3 minus T2, so they in time intervals. So time intervals are better just for interpolation because they have the duration. So we can say, okay, this is 1 second, this is 1 second, this is 1 second, or this is 1, 2, 3, 4. I think that I'm going to use the delta times because it's easier just to think to say, okay, I want to keep this movement here 1 second. Okay, let's do that just to keep the delta times. So this keyframe starts at 0. Mm, and this is the lapse time, and you need to provide this one, elapsed time, this one. Let me check how it works. It's the same it worked with animation nanoseconds duration of each title. So okay, it was the same here. Okay, so this is a different animation. Let's start something more. So let's move. Okay, let's start with this one. Oh, oh, better. Okay, so when we maximize or we create the random, so we can replace maximize with this new animation. What we will do is just to increase the size to 7% of the maximum window, then decrease again, and then maximize. So it's more or less like a twice animation. Okay, so we need to implement this here. So in the new, we need to provide this input. So this is a private. Uh, this is a float array. So this is called values, and we have a new one long that are called keys. And the loop times. So let's copy the loop times. I think I'm not going to use right now, but for the future. Okay, so this way we are going to implement this one. This is the initial. It will load the values here when it's loaded. So I expect no errors here. And when the animator calls the get animation value, it will get a null. Or get animation percentage, it will get null, null. Okay, so let's check what happens. Okay, it does not work. Okay, the null pointer, so it does not like the null pointers. So null pointers, they don't like the null pointers. Animator is not prepared to receive the null pointers. So null pointer, animator, get animation value, get animation value. When it get animation value, it's calling this one. We have different implementations. So, okay, we call here when we get. Okay, there are two implementations. So linear float, okay. So linear float provides the value, get value, but keyframe is not yet implemented. That's why it's returning a null value. So I don't know why a null value is here an issue, because I output component are all wrong. Okay, because it's so let's implement that. It's better just to implement that. Okay, so starting. The get name is already done. The reset origin, it's easy, so we just copy from here. Time origin. So we need to add that one. This is just to use the start time when it's called, just to fix which is the starting point of the animation in global time. So it's done here. So we have this already done. Is animation ended? It's complex, so we will leave that for now. So we are going to focus in get animation value. In get animation value, it's just to get the output. So we want to get the output. We want to get and these values depending on when it has been called. So we can reuse this one because it's just calling an internal function. The index, this is time. Okay, yes, it's better to say it's time, not index. It's time, and this is also time. So let me change here. Okay, so we get, and we need this to create this function. So we are going to implement here the logic. So this is an internal, a private function inside of this class. So it's managing how it works internally. So these are the methods, the functions. So how it works? So we need to provide a float, and we have this information, values and keys. So let's copy because there is get value. Get value needs get loop value. Get loop value needs the percentage. Get the percentage. So we need something like this. Okay. Okay. The first thing that we need to know is in which step of or which is the keyframe between two which two keyframes are we right now. So uh, we provide the time right now. So the lapse time is now minus the animation starting point. So it will provide the time between the starting animation right now in nanoseconds. So in the past we use time range. So time range is the maximum time is the window of time. So let's create a new here private private animation or private long, yes, uh, animation duration. So this is just to provide to what is all the time. So we just need to sum up all these keys. So it's like we can create a loop for long key in keys, these keys. What we are going to provide is just long. So let me add a long. This is the duration. It's 0 by default. I'm going to return that duration. So it's duration plus key. Yes. So they will add 1 plus 1 plus 1, so it's 3 seconds. So this is what we need just to say, okay, this is the animation loop. The animation one loop is this. So the time range is the animation duration. So okay, so if elapsed time is greater than the animation duration, so in this case is the time range. Time range, the minimum time could not be 0. So elapsed time, it could start. So let me just here just to provide 1 second. If I provide here 1 second, it means that the animation starts 1 second later. So it does not start immediately. So it's a delayed animation. So we can delay the animation. So when we here add all the durations, the first one must not be included. So let me change this one from and e equal 1 e minus um, length. So let's skip here the 0, and just add this dot keys yi. Okay, so we are skipping the first one. Okay, so if elapsed time is greater than the duration, we have subtracted the animation time origin. So if we have subtracted the animation origin, and we can be inside the loop or just waiting. Okay, so okay. So no, let's go back here. We need to include the first one. So we can be before the loop, but the loop starts at 0 always. So this just means that from 0 to 1, we can need to provide this value. So, and when it's greater than 1, 2, 3, 4, we need to provide the maximum value. If we want, we can also provide a null value. So let me remove the loops just to simplify this one. So if current loop, I don't want loops. I don't care about loops. So elapsed time, no, I need to remove loops. So if current loop, if elapsed time is greater than time range, we need to subtract the time range. Okay. So if elapsed time is greater than the 4 seconds, we move it back inside the loop. So we add a current loop and we subtract, so we get the time, the remaining time from the elapsed time inside the loop. So after this loop, we get the remaining time. So if current loop is greater than the loop time, return no, return 1. This is the percentage. Okay, so this is elapsed time minus mean time. That it's the first keyframe. Not sure if the percentage is good in this case. No, I think that we are I start from scratch. I don't like the percentage here. So okay, how can we provide the value? So we need to return a float. So float value. So let's do a dummy here. Okay. So when we start, we need to get the remaining time. So the elapsed time. So elapsed time. So this is from the beginning of the animation right now. And now, so it could be greater than our loop. So it could be greater than, in our case, this 4 seconds. So it could be 8 seconds, 12, and whenever it goes beyond, we need to bring back to the loop. So it could be just with elapsed time. We only need the remaining, so we can do an integer division with the duration. So let's add here, this is a long anim duration is equals to the function that we have created. So if we divide it and we get only the remaining, it's the time this is the remaining time. So the remaining time, I don't know if it's the on the loop time. This is the time inside the loop. Inside loop time. So here we are sure that this time is between 0 and 4. So it's not greater than 4, because if this is greater than 4 divided by 4 is an integer, so it will be 0. Or if it's 5 divided by 4, in the remaining it's 1, so it will get 1. So once we have the time inside the loop, we need to check which is the keyframe. So this could be check because we have only the delta times. We need just to create a loop. So so this is a while loop. So let add here. So while inside loop time, if inside loop time is greater or equals, it's greater. If it's equal, if it's equal, it doesn't care which keyframe we use. If it's greater than this keyframe, so let's start with the keyframes. Index equals 0, or key index 0. So for the index 0, we have the first key delta time. It's the key index. So our first delta time is 1. So if the remaining time with the inside loop time is greater than this key delta time, that means that we have enough time to move to another keyframe. So just inside loop time minus key delta time. Okay. So, and we calculate the new key delta time as the next one. So let here key index plus plus. So we move to the next key and check that one. So we will end that here. So at the end of this while loop, we will have the key index. The key index will show us the keyframe, the lower keyframe, because we are between two keyframes. So if it's key 0, 1, see it's this one is key 0, 1, 2, and 3. If the time is lower than 1 second, so it means that we have not reached to the first keyframe, so we need to provide this value. I think this way is complicated. Maybe we need to start always with 0. It will be easier if we start always with 0 and implements the delay inside the values, because adding a loop here it's more complex. So let's start with 0 and later we will check about the delays. So that way we are sure. If inside loop, so imagine that inside loop is 0, 0. If it's greater than if it's greater only, so we get the lower end, the lower keyframe. So index, the key index, key keyframe lower index. So yes, lower index is 0. So we will get here the lower index. So here we are between this one and this one plus 1. So this is the two indexes that we need just to interpolate. So we just need to get a linear interpolation between these two ones. So so we have also the inside loop time. So this is the delta time. So the delta time divided by these um, keys, and what I want to get is the duration. I need to define if this is the duration to reach or if the so, and the problem here with this one is that you have this value at this moment, you have this value at this moment. So 1 second belongs to the right value. So inside loop, you need to divide with the next one. You need this one. So because you are in the next loop, so you need the time of the next is the duration of the next keyframe. So this is the percentage. Okay, maybe we need to add a float here. No. Okay, so we need to store here in some way. This is the percentage. So the percentage of this one. Inside loop is long. Inside loop is long, and this is long, so it's not going to work. I need to change one of these ones to float in order to get floating division. So I have the percentage, so the output value, the value is a linear interpolation between the value at the keyframe lower index and keyframe lower index plus 1. So if the percentage is 0, so this is these values, it's this is the minimum value, is the left plus the right, that is more or less the same, multiplied by the percentage. Not this way, it's not. It's the division, so it's unless this minus this one. So let's do it bigger. Okay, so let's imagine that this is 2, this is 4, and this is 2. Okay, so the percentage is 0. When the percentage is 0, is providing this one. The percentage is 1, 1, 1. This and this is okay. So that way it returns the value, the correct value. So yes, that should work. So let's check. There is an error here, key index. Oh, I have renamed it. So let's try. Okay, it's giving an error here. Null pointer, put row all, why, with get animation value. Okay, let's move this random to the end. So let's be the third animation instead of the first one. So no, it's not there. So why? Take ultra or ultra null pointer. Get animation value. Animator get animation value. Why it's null? Let me remove. Okay, it's not working due to the new one. And what's happened with the new one? Animation keyframe plot. Call it. And it's float values keys. Okay, this is an array. Okay, maybe I need to check if it's defined object builder. Build complex properties. We are using long array integer long array is here, so long array is here. If float array is here, so it's working. So that works. Okay, here there is an error. Let's check again. It seems that error is related with the building of the objects, of the entities components, and not related. This is the new animation, so it's not working. But okay, more or less it's doing strange things. Okay, array in the Lotus bones here. Keyframe float. Okay, so in some way we are getting the why. Okay. Because we have 1 2 3 seconds, so the duration is just duration plus the keys, so it's adding 1 1 1, so we will get 3. We will get 3, so that's correct. The duration 3. Here we start the animation. The duration is 3 seconds. The lapse time, I don't care, but inside loop must be between 0 and 3, so let's add here an output just to check. Inside loop time, so just to confirm that it's between 0 and 3. And so we start the keyframe lower index is 0. So we start with the first one, so we can interpolate between the first, the 0 keyframe, and the next one, that is 1, or between 1 and 2, or 2 and 3, because we have 4 keys. So if the inside loop is 0, key delta time, okay, I think this is an issue. Key delta time, it's 0, so always inside loop is going to add a new one. If it's 0, if inside loop time is greater than, okay, maybe if we add the duration of, it's better to add the duration at the beginning. It will be easier to say that key 0, the lapsing is 1 second. Mm. Hello, señorita Lara. Welcome. Uh, so maybe it's easier just to add the duration, because if not, it always skips the first one, so it moves inside loop to the first. Mm, so if not, we will need to say that here the key delta time is the next one, so it's the next one. So the key delta time for the first frame between 0 and 1 second, it must be the 1 second. So if these are defined as not delta times, I think that we need to define this clearly, what it means. If it's the duration of which keyframe, mm-hmm. If it's the duration of the keyframes, I think it's better maybe just to say that is the duration. It could be that. It's better just to for, so let's move back to the thinking window. So if I have this one with times here, I can say that T1 is at 0 and T2 is at 1, 2, 3. So we can, it's easier in order to define them just to say at which seconds, global seconds, to say, okay, this is 0, 1, 2, and 3. This is one option. Another option is just to provide the time interval. So I can say T1, between T1 and T2 there is 1 second, 1 second, and 1 second. But how to code that? So we have the minimum value at T1 and we have minimum value at T2. Maybe T2 it's easier if we add here not this time but the global time, to say okay 0, 1, 2, and 3. I think it's easier to understand and to program, to say okay, when we start 0 we have this value, when there is 2 seconds we want this value, and with it's 3 seconds we want this one. So maybe I'm going to change it to be the absolute time from the starting of the animation. So let's change to let's redefine that to the duration. So it's better to say, okay, we want this value at 0, and this value at 1, and this value at 2, and this value at 3. So the duration, instead of this one, the duration, it's easier because duration is just, we just need to return the last value. Return these keys. Which one? The last one. So this keys length -1. So if the right, this one has 1, 2, 3, 4, 4 elements, the length is 4, -1 is 3 because we start with 0. So this is element 0, element 1. Let me create more space here. This is element 0, 1, 2, and 3. Okay, so it provides right now the duration. So the lapse time is the same, it's a loop. So when we end, we start subtracting all the loops. So this is with an integer remaining time. So instead of doing the division and getting the integer part, we get the non-integer part, so the remaining of the division. So with inside loop, so then we start with the keyframe. So we start with this one, the 0, the delta time. So the duration of this one is okay, because inside loop is the remaining time, so we need to check in which of these intervals are. So we just need to get one of them that is bigger than this one and lower than this one. So that's the condition. So, so I think so. We start with the keyframe lower. So we start with 0. Delta time, we will say that is 1 additional. So the duration of this one is 1 second. So if it's greater, if inside loop is greater than 1 second, we need to move to the next frame. So, so here we don't need to do this one because right now it's an absolute value, so they are not deltas. So we increase the frame lower index, so we move to the next one, and we get, instead of key delta, here is I need to rename. This is key absolute absolute abs, abs, absolute time. Yes, absolute time, because there are global time. Right now they are not incremental, so they are absolute times. So we get the absolute time. So again, if the inside loop is greater than that absolute time, so we move the lower index. So at the end we get, this is the lower index, and the percentage is the we need just to, between this index, the keyframes, it will be the value, and this is the key. So we have one key value, that is this one, and we have another key, that is this one plus 1, and the value is exactly the same. So we need to create a linear interpolation between these ones, between the values. So we have the inside value, the inside loop time. Inside loop time in this case is minus the lower, minus, yes, minus the lower. I need to subtract the lower key, and then divide by the time range. The time range is the difference between, because it's absolute, between 3 and 2 it will be 1 second, between 2 and 1 it will be 1 second. So I need just to get the range value, so in this way. So this is a float between this divided by this. So inside loop minus not keys, yes, we subtract the starting of the keyframe, the key interval, and we divide by the key interval size, that is the difference between the keys, because they are absolute values. Okay, so we have the percentage, and the value, it will be the minimum value, so it will be the value of the left keyframe plus the percentage multiplied times the difference between the value of the here plus 1. So the next value, okay, let's set this late. So we have a linear interpolation is the left plus the percentage that we have or the next keyframe value minus the previous keyframe value. So this is the the keyframe, the interval value increment, the increment. So when percentage is 0, we provide the left one. When percentage is 1, we provide the right one of the key interval. So we provide that value. Okay, so let's check if that it works. So at the beginning it will do, remember that we have 3 animations. So right now it has completed the maximize. When I click again, it will do the minimize. And when I click again, it will do this one. So it's more or less a maximize. So let's click. And it's doing strange things. Okay, so here the inside loop, what we have said is that it must be lower than 3. So it needs to do loops between 2 and 3, between 0 and 3. So if all these values are, and what it happens is that when it reach to the 2 seconds, so when it's between 2 and 3 seconds, so it's between the last 2 keyframes, so it's between mm, here and here, between 0.3 and 1.0 to 3, it gets an what is out of bounds, because there is some error here. So let's check that condition. So we start here 0. So suppose that this is a little greater than 2 seconds. So keyframe 0, key absolute. Okay, we get the next one. So this is 1 second. If inside loop greater than 2.5, for example, greater than 1, yes. So we move the index. So index is right now 1. Key absolute value is these keys. So is the next one. So in this case is 2. Again, is 2.5 greater than 2? Yes. So we increase. So right now the index is 2. So key absolute time is the next one, that is 3. So, no, sorry. Okay, so we start with 0, 0. It checks the 1. 2.5 is greater, yes. So here the index is 1. Oh, this is a mistake. This is plus 1, and here we need that plus 1. So when it's 0, we compare with the next one, this one. When we increase to 1, we need to check the second. So this is 2 seconds, so it's greater. So we move the lower index to 2, and we get the value of 2 plus 1, so it's 3, that is 3 seconds. It's 2.5 greater than 3 seconds? No. So the key frame lower index value output from here is 2. So here we compare. So right now it must work. Maybe there is some situation. Okay, it must be greater. So I don't know if in some situations it could be greater than 3. I suppose that no, but so let's start. This is the maximize animation. So right now the minimize, and now the random one. Okay, it works, but it's in a loop, so we need to stop. So what it does is just to, I'm going to almost maximize, almost minimize, and maximize, but doing again and again. So I need to stop that. So it's working, but I need to stop. I need to, the loop times, I need just to say, okay, I don't want to do it again and again and again. So this works. this works for, this is a get infinite loop. So how we can detect that, uh, how we can check that it's only one loop. So we have more or less the code here in the previous one. So in the percentage, get value, if loop times, get loop value, get loop value, get loop percentage here. Current loop is 0 if elapsed time is so this is the code just to check. This is the code for the percentage, so this will return the percentage. This is more or less the code that we need. So this is working. So let's do here. So current loop is 0. Elapsed time is greater than the duration. If it's greater than the duration, increase the loop and subtract. Okay, I think that we don't need this one. We can create the division instead of that, and that I can just do like here that we have done. Okay, here. Okay. And the loop is calculated here. So instead of doing that, I can do R integer division. So elapsed time. Elapsed time is long. Animation is long. So I need to cast one of them to float. And what's I cannot convert from float? I want the int. Yes, I think there is a math div floor division. Yes. Okay. So what does this function? Div measurement cat cast to int. Return the largest close to positive infinitive long value that is less or equal to the algebraic equation. There is one special. So it's a floor division, so it does a division between two of them. I don't know why it's not working with longs, because with longs it must work. Just divide them. Okay, it works. So we just need to do an integer division, and with an integer division we will get only an integer. So we will get 1, 2, 3. So inside loop this time we are getting the remaining. And here we are getting the elapsed time divided by animation, so we get 1, 2, 3. So if it's greater, so here if current loop is below or equals this dot loop times, and then do all of this, and else, if it's else, we have several options, but right now we are going to provide the last value. So we are going to provide that value is the value of the last keyframe. So in these values, the last keyframe is this dot values length -1. This is the last value. So we are going to provide the last value. In this case is 1. Okay. So let's check, and I hope it works right now, and it does only one loop for that very strange animation. So minimize and do the random, go back, go, Hmm? This is twice. Okay, it's doing it twice. Why twice? Go back, go one. It's doing two loops instead of one. So there is some this loop times. I think it's okay. Okay, and there's a problem with the definitions between because uh, during the first loop, uh, if we are if this loops takes 3 seconds, so between 0 and 3 seconds, the division returns 0. So 0 is the first loop. And if we are between 3 and 6 seconds, so for example 3.5 divided by 3, the integer division returns 1. So 1 is the loop, but the loop the number of the loops starts with 0. 0 is one loop and 1 is, so what we need is just to remove one of here, so, or just here, because the the first loop is 0, is when we get 0. The second loop is when we get 1. So if we provide here 1, and that doesn't mean that we want two loops, that means one loop, but for the internal programming language, and this must be 0. Okay, so right now it must work. So we have added some keyframes. So we can do strange things with this one. So let's check. So this is the random. So it tries to maximize, go back, and ends the maximizing. Go back and forth. So this is what we have added with the keyframe. So let's do something more. So let's, for example, do it bigger. So for example, let's say that it takes 2 seconds and we are going to do a very big window, so greater than 1. Then we are going to be back and later restore it to the value. So it could be 3 or 4, and this is 5. So it will take 5 seconds. Okay. So let's try this one. So right now I'm going to when I maximize, I'm going to maximize a bigger window that we had. So let's check. So this is the current size of the window. So minimize is the previous one, and in the maximize, it's going to pop up a very big window, go back, and leave the current one. So this is the big one, back, and it's there. So we can add whatever we want, and for example we can stop the animation at some point. So for example, if we want to leave the animation sometime here with that bigger size, so we can keep it, for example, 1 second. So let's add another key here and keep 1 second. This could be 4 and 5. Okay. So I'm going to keep during 1 second. Okay, let's add more. 2 seconds. During 2 seconds, it will remain at this maximum size, this bigger size, 1.5 bigger size. So what we have with the keyframes is that it's not only a linear, it could be whatever you want. So minimize. And right now I'm going to run the keyframe animation, so it will maximize to a bigger size than the original one, keeps 1 second at that position, go back to minimize, and then restore the standard one. So 1 second here, back, and again. So again, minimize, let's do again, keep 1 second here, go back, and again to restore the size. So this is what you get uh, with these keyframes. So you can do some amazing things. So right now we are only managing one parameter that is the same for height, width, and position. But later we can do what I said, that to move the window here, 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 and do a loop or whatever you want, and then minimize. So it could do whatever you want because it's defined as a step. So you can say, okay, this is a keyframe here. Then move here. This is capture. This is another picture, another snapshot, second keyframe. This is the third keyframe. And then go to the minimize position. So we can add all these steps in the animation. So it's just to a stop motion. So just to move some steps like undo the animation. So it's working. Go, stops, move back. Okay, so it works. So this is the animation with keyframes instead of just to have a linear. So the linear animation, it's a linear interpolation between minimum and maximum value. And the keyframe animation use multiple values and tries use linear interpolation between of them. That's why between 1.5 and 1.5, it's just to keep the state. So no changes here. So you can, some way, you think that the animation has stopped, but it's not stopped. It's just that during that keyframe, that yes, between those keyframes during that interval, key interval, there is no changes, no visible changes. So and that works. So I think time is more or less over. I need but the next one is to create for next day. So let's check what we had for today. Create an animation type with keyframes, so it works. And for next day, what it's is what we have a pending is to create the same keyframe animation, but instead of animating a float, is to animate the global transformation. So instead of providing here, what we have is a float array. We will change this one just to provide, uh, I think it's an array of arrays. So it's
Your mission
array
is
of
complete.
transformation. So I need to check. But what we want is to provide in each keyframe a transformation, an object like this one. So to say, okay, during this interval, the picture is this position. The next keyframe is, and we need to provide all of these parameters. So maybe we can we can check how to do that, or maybe it's an object array. So it's complex. Yes, maybe it's a bit complex just to define in the definition files, but maybe providing an array of objects, and the objects could be the transformation. So that could be done for the next one. So right now we have the new class with an interface. So as you see, no changes in animator. Animator is working the same way with these two animations instead of having a lot of switch states for each type. What we have is just an interface with what we need, and each of these different classes is implemented the interface and managing on their own internally what's needed just to provide an output value. The output value also is an object. So animator, it doesn't care about what's provided, because the value, it could be just a float, a double, or whatever. It could be a picture, or it could be a transformation object. So it doesn't matter for the animator. Animator just provide an output value. How it works, it it doesn't care. So I think it's all. Thanks to be here. Thanks for listening, and see you in the next session. So thank you. Bye bye. Have a nice day.